What do you have to do when you go further into it? Because that's kind of where we're heading towards today. Drop this, multiply, add, multiply, add, multiply, add. It should not.
Negative 6 is not 0.
5, 30.
That's a negative 6.
No, 0. The 0 is supposed to be negative 6.
You know what? I just saw the 6. I didn't see there was a negative 6. I'm sorry, guys. I looked up and I thought the 0 was 6. Where was I? 1, 6, 0. Okay. So we know that positive 6 is a 0. If positive 6 is a 0, what's the term that creates the 0? Good. So right now we have factored out an x minus 6 of this ugly original cubic. So we have a 5x squared, 3x plus 1. Now at this point, if you had to factor it further, you'd ask yourself, what is 5? You had to either get 3. Nothing. So what I was asking you guys to do yesterday was to use quadratic formula. So negative b plus or minus square root b squared minus 4ac all over 2a. So you get 9 minus 20, which is negative 11. So your ugly values here become the square root of negative 11, otherwise known as, you have zeros at 6 and negative 3 plus or minus I root 11 over 10. And those would have been your 2 zeros. We're actually getting that a little bit ahead of ourselves, which is fine, bless you, because this is the kind of stuff that we kind of continually do over the course of the next few days. I talked with 12th hour yesterday about the possibility of getting through a little bit more of this a little bit quicker. And as I was working through it, trying to see if we can be able to test on Friday as opposed to next Monday, I can't. I don't think there's enough time to. I don't want to rush through something and put too much pressure on it. I think it'd be easier if we just take the extra 30 minutes to go through some of these things. So we'll still leave it for Monday, okay? Okay. There will be calculator, non-calculator though. There will be parts of that I'll ask you to do with the calculator and parts that we'll take the calculator away. Just so you know on that one. All right. What else do you want to look at? Are we okay? All right, so we have negative 5 is a 0. 4, 9, negative 52, and 15. Yay! I did it right because I got a 0. Yay! Were you happy doing this? Or were you just cursing my name a lot? Or a lot less? You're being kind to me right now. So if negative 5 is my 0, my term is x plus 5. And then I have 4x squared minus 11x plus 3. If I'm trying to find my other zeros here, I'd have to use quadratic formula. So we get what? 11 plus or minus square root 121 minus 4 times 4 times 3 all over 8. What is that? 40, was it 73?
Or 73.
Yeah. There's your zeros. That's it. All right, make sure your name's on it. Let's do stuff today that happens when you don't know a 0 to start with. How do you decide what numbers to choose? And this is where having a good eraser is your best friend. Yeah, I thought most of you guys did it all on the same page, the long division and the synthetic. So, of theorems or anything like that, what I want you guys to look at is how do we come up with possible zeros to synthetically divide by? Well, what we do here is that we look at the factors of the tails. What I mean by that is I look at all the possible factors of 12 take all the possible factors of 12. Notice I'm not worrying about the sign because I can have plus and minuses here and there to make it all work. And I'm going to divide that by all the possible factors of the leading term. Remove this, factors of constant over the factors of lead term. Because my leading term coefficient is 1. So basically what I'm doing here is I'm going to start fishing for zeros. And how I fish for zeros is I list all the possibles of 12. Well, what are your factors of 12?
1, 3, 4, 6. Is it really in the right order?
And it's all divided by 1. So what'll happen here is sometimes when we have leading term coefficients that aren't 1, we could get fractional ones. So basically this just tells us that you might have to fish a little bit to find your first 0. Okay? But knowing that you're using synthetic division is quick. It's adding, it's multiplying and adding. If you don't get a 0, you erase and you start with the next number. If you don't get a 0, you erase and get to the next number. There's no magic bullet about where to start or anything like that. You just pick a number and go. So basically, this rational zero theorem, it boils down to this whole nonsense of words of basically this. You're looking at your tails. Factors of the constant divided by the factors of the leading term coefficient. That's it. It's much easier to think of it that way. We're working with tails. Okay? We're saving puppies. See, working with tails.
For the tails, again, can you remind us, like when it's like this?
Yeah, when it's like that, like when you're dancing,
Yeah.
when it's down up, you are first term's positive and it's an odd exponent. So this would be a down up. This graph would look like it would look like that. Yeah. So here's what we do. When we're trying to figure out what our first 0 is going to be, well, what's the first in this list? 1. So you start with 1, and you use synthetic division with 1, 2, -11, and -12. If you get a 0 at the end, that means 1 is a 0. So drop the 1. 1, 1, 3, 3. Not going to happen. I notice right away, 1 doesn't work. So what do I do? I erase it and I go to -1. And that's where I'm getting at. Synthetic division, usually you will find a 0 within the second or third try. It doesn't take long. That's why we show you guys synthetic division, because it's quick. Okay? So if I go through synthetically with the -1, still first step is bring down the first term. -1 and 1, -1, add that, we get 1. Ooh! I found a 0. Yay! So if -1 is a 0, what's its term? Good. So now I'm down to an x plus 1, and here is a x squared plus x minus 12, which means, what do we get? I can factor that further now. What times what? What is it?
X plus 4.
Done. What this is doing is that it's making you find the first 0, as opposed to yesterday, they told you to start with a 0 at 6, told you to start with a 0 at 4, whatever. Yes, sir? The 0, because we're dividing by zeros, so if the 0 is -1, what term creates -1 as a 0? X plus 1. That's what. Yeah. That's why I keep bringing up zeros and terms. That's how this stuff works. Okay. Good. Don't want to touch it. I was just joking.
It smells like manure.
we
It's so bad.
we were next to a cornfield.
Yeah.
Who was the last
Like,
one in?
someone just like take their cows. and
Trap.
just, like-
I shouted this morning.
No, it's like not even like a person. It's like manure.
All right. So let's do this. I know that sometimes it'll say list the possible. Getting accustomed to just listing possibles is a good thing, but it's not always something you're going to do because listing's great, but why not find the zeros? So if you have to list them, you already wrote them down, why not find them while you're working on it? So what are all of your factors of 56 over 1? Well, 56 is 1, 2. Is it divisible by 3? Remember how to check it's divisible by 3?
Yeah, that's the
Good.
which that isn't.
Is it divisible by 4?
Yeah.
Yes.
If it says
Or
5,
no,
it doesn't have to be divisible by 4.
No.
Not necessarily.
Four and 14.
Yes, like it's, I can't
Yeah, 4 and 14.
So we have 1, 2, 4, and then it's 7 and 8.
7, 14.
She can't smell it. I can't smell it. It's stressing her out.
Plus or minus,
really
I'm really
what?
You need a blast. You're blessed. That's the worst thing ever.
It's like over if you walk like there, you can smell it.
Thank you for the plus minus.
Like I walk by the window and it just smells. Are you serious? I don't know.
I've been confident.
She's like, I hate doing
That's how you list them out. Yes, sir.
I'm wondering how people are scanning anything because those windows can't open.
Because still we get ventilation from the outside. Okay. So that's what it means to list out your possible zeros as you go through. It's nothing more than that. Ooh.
Like, do I need to leave or just like?
I agree with stuff. I need to know what room.
Ooh.
At least you don't get to smell it anyway.
Now you know the smell's gonna go away. Just let me hang in there. I was like. So at this point here, again, when you list out things, it's just you're looking at the factors of the tails divided by the factors of the front. That's it. Okay. It's very rare that I'm going to ask you to do that. I'm just going to ask you to factor it and find it out because this is using synthetic division is the easiest, most efficient way to factor upper degree polynomials. It works every time. Okay.
You're lying.
Let's try another one.
You're just trying to fit it. You actually don't smell it.
If I don't, I just admitted that I didn't smell it. Now it's supposed to work.
Good answer.
Let's factor this one.
Get it?
I know. I didn't like realize.
Let's factor fully. Another quick reminder. 4th degree polynomial, how many terms should it have in its sequence? Should have 5. How many possible zeros are there if you have a 4th degree polynomial? 4. How many changes of direction could it have up to? 4th degree polynomial has a possible 4 zeros. It has a possible 3 changes of direction in the graph. It have what? 5 terms in the sequence. What do the tails do in this one? We have 2x to the 4th. We are up, and away. Sorry. This one's up. Okay. This one will be up. So we look at our factors. We look at the factors of plus minus 10 divided by the factors of 2. So what are your factors of 10? Well, 1 it would be plus minus 1, 2, 5, and 10 over 1 and 2. Now, that just means that you have plus or minus 1, 2, 5, and 10. So there's 8 right there. And then you have plus minus 1/2. You have plus minus 1, which is repeated. Then you have plus minus 5/2, so now we're at 12. Okay, you can see fingers. Yeah. So technically, there are, in this sequence here, there's a possible 12 zeros that you could theoretically synthetically divide 12 times before you find one. Won't happen, but it is a possibility. So as you go through these, I'm going to recommend that you don't try to start with the fractions. You can, there's no reason to, but why not always start with the easy 1, 2, -9, 8, 9, and -10.
That's repeated.
It didn't work. Okay.
Oh, -1's gonna work now.
And here's what's cool about this. Let's say if you screw up and you say it doesn't work, you go to the next number and it works. Is that okay? Because you're going to have 4 possible zeros here, so you're going to find one eventually.
Why do you have it?
Where did I miss?
Works. Yeah, that's not. I got it.
All right, so 2, -7, -7, 1, 1, 10. What did I write there?
You put 14. Yeah, you put 14. You put 14. I don't know. I think you multiplied 7 by 2.
Oh yeah, you're right. Oh, oops. But here's the thing. Let's say I did screw that up and found it was not a 0, and I went to the next one and I found one that was a 0. I would have eventually realized that it was screwed up because sooner or later that 1 would show back up. Okay, it would show back up. That's all. So we go back to here. We know that 2, what was this? -7, -7, 1, 1, 10, 10, and a 0. So that means that 1 is a 0. So I factor it out and I'm left with an x minus 1 term. Everybody okay with that? So now I'm left with 2x cubed minus 7x squared, 1x plus 10. I don't want to factor that. So, synthetically divide again. Right underneath this, just go again. You obviously don't need to worry about this last 0 now. You're stopping at the 10. Here's my suggestion. Do we all agree that sometimes you can have repeated zeros? That just means it would have been like an x minus 1, or x plus 1, one of those types of deals. Whenever you go and you drop down a degree, you found a 0, recheck that 0 with the next set. Because, if possible, this could be a repeated 0. So we just check it real quick. And it's not going to work, okay? So we know it's not going to work. So we know 1 is not a repeated 0. So I erase, and I go to -1. And I do the same thing. -2, -9, 9, 10, -10, and 0. I now know that -1 is also a 0, which means if -1 is a 0, what was its term? X plus 1. So now I'm factoring this thing out. I have an x minus 1. I now have an x plus 1 that's come out. And I'm left with 2x squared, 9x, and a 10. Could I try to factor that if I want? What times what is 20 to add together to get -9? -4, -5. So I can go ahead and it's a joke.
Did you get dressed?
The manure's back. That was a joke. Anyway, so now we're at this.
Do you smell it?
Yes, I smell it now.
Do you smell it?
Yes.
Could I factor that? Or can I use synthetic division? I can factor it. What times what's 10? So we do our split middle term. So I know I can do that then and factor it out the rest of the way. What's that? Does it matter? Why? What's my GCF here?
Because divided by 2.
Yes, ma'am.
You like did it again with like the 2 and the -7 and the 1 and the 10, not the original numbers.
Because what happens here is that we've already factored out that first term. Every time you synthetically divide, you drop a degree. Here we had a 4th degree. Here we're at a 3rd degree now because we took out the x minus 1 that was inside of this. We've divided it out. So every time you synthetically divide, you're dropping a degree of the polynomial because you're taking out terms. We took out an x minus 1, we took out an x plus 1, and now we were left with a quadratic. And usually when you get to the quadratic portion, it's easier just to go to quadratic formula or use your, multiply your tails together and go. Yes, sir?
We also now know that -5, no, 5/5, 5 halves was a
5 halves was a 0. So now we're at x minus 1, x plus 1, x minus 2, and 2x minus 5. Those are my 4 terms, which gives me my 4 zeros of 1, -1, 2, and 5 halves. Yeah, Travis?
How do you get plus or minus 10 over 2?
The rule is when you're listing out all of your possible zeros, you take the factors of the tail divided by the factors of the leading term coefficient. That's how it works. That's the rule. You always do that. You're looking at the factors of your tails, both tails. It's the constant divided by leading term every time. That's how you list them. Okay? And that's how these things factor themselves through. Note it's not a very difficult process. What happens is sometimes it just takes a little bit of time. That's it. Okay? That's it.
Wait, how do you get like 1, 2, 5, 10 over 1, 2?
What are all your factors of 10? 1, 2, 5, and 10. What are your factors of 2? 1 and 2.
Yeah, but why don't you put like
It's because the first thing is to change the model. There's 2x to 4.
that doesn't make sense? Because
What are your factors of 10?
No, I don't get like why you would put like wouldn't there be like 1/2?
Yeah. Yeah, it's in there. I just don't list it out. I mean, these are all my possibles because this means I'm going to have 1 plus or minus 1, 2, 5, 10, 1/2, and 5 halves. Those are all the possibles out of that whole list. There's 12 of them total. I just don't rewrite them out of here. I just pluck them out here. Because what my hope is that I'm always going to find zeros with my integers before I get to the, or not with my whole numbers before I get to the fractions. That's all. That's it. You don't have to list them out like this. There's no reason. Just pull them out of here. Okay? That's all. Let's do another one. Oh, wait, we just did this one. Hey, guess what you'll be able to do? You'll be able to find real and non-real answers, depending upon what the question asks you. If it asks you to find all real answers, what are you going to give me?
Real answers.
Real answers. It says find all zeros, what are you going to give me?
Fake answers. And
Good. You give me the real and imaginary solutions. And I'll show you how that looks with just this one example. It's pretty easy to set up. So, we have a 3rd degree polynomial with 4 possible terms. We don't have any placeholders. My constant value is 8. My leading term coefficient is 2. So my possible zeros here are going to be the plus minus 8 over 2, which is plus minus 1, 2, 4, and 8 over 1 and 2. Now, Trap, this is where you're getting at earlier, is that why don't I list out all the fraction ones? Because if I look at this, what's 2 divided by 2? It's already taken care of. What's 4 divided by 2?
2.
And 8 divided by 2 is 4. So really the only fraction one that I never have to worry about is plus minus 1/2. Because sometimes you'll have duplicated throughs because of the fractions. So I don't list them, I just know that they're all mixed in with here. Usually I'm gonna get my factors out before I have to worry about going to fractions at the end. Okay, those are usually the last ones you worry about. So don't worry so much about the fractional things, okay? So I've got my possibles. I'm gonna use synthetic division because synthetic division is pretty sweet. I start with 1. I go to -1. Excuse me. What's that, -7? -1 doesn't work. I go to 2. -2 does not work. I go to -2.
You just mixed up
No.
your mixed up your rooms because -2 doesn't work in the same place.
Hey, -2 did.
Oh, okay.
So notice this time we had to try it, our fourth time is a charm. And that's what I meant by telling you guys, don't whine about it. It's really easy. It's just adding and multiplying, erase. Add and multiply, erase, and see if you find it, okay? There's no silver bullet to get you there, especially if the numbers are nasty looking or they're a little bit more difficult. I mean, if you wanted to take a crapshoot and try and see if you can kind of guess your way into it, by all means, go for it. Anybody else need an eraser? Anybody else want an eraser? Anybody else? Sorry.
Where did it hit?
These are tough to throw to get an arc on them.
Where did it hit then?
Why do I need an eraser?
Who? What if I can snap it?
How did you do that?
That was awesome.
How did you do that?
Hey,
You've never done that before?
No.
Somebody give me a nickel.
Sorry,
So when you get down to this,
He's got like 10 of them.
you found that -2 is a 0, so the term is x plus 2.
You can actually go further with that.
Yeah, you can continue on if you want to use synthetic division again. Always double check to see if it's a duplicated 0. So you have -4, and you know that's not going to work. So if you want to use synthetic one more time, go to 4. You have an 8, -1, and -4. So then you know that 4 is a 0. So if 4 is a 0, its term is x minus 4. Now you started at, guys, you started at a 3rd degree, you went to a 2nd degree, which means this one is your singular degree. So this is the term of then 2x minus 1.
Wait,
So your zeros then are at -2, 4, and 1/2. Synthetic division. It's awesome. So fast to factor.
Mr. Murphy, wait, where did you get to 4?
I just, instead of factoring 2 times 4 to add a -9, which you can do, I figured I must use synthetic again, try it.
Wait, and then where did you get the 1/2?
I did say that, didn't I?
What?
Well, I think it is. I think it's quicker to use synthetic division instead of trying to factor 2x squared minus 9x plus 4. So yeah, what times was positive 8 to get to -9? Because then I'd have to do all that grouping, so it's not worth it. So I've got the 4 as a 0, and then I'm left with 2x minus 1. So you're at
You
-2.
just get the 4 and 0 by going to like the number.
Yep. Yep. Because what we did here, guys, what we did here is we've already done plus minus 1, didn't work. We did positive 2, didn't work. -2 did. I double checked to see if it was a duplicated 0, and then I went on from there. Okay. I'm trying to think if there's any more of this stuff. Yeah. What can happen then is that with this, and I've been leaning towards all of this over the past day or so, when you get down to these possible zeros, is that when I get to something like this where it's a 5th degree polynomial, what do I have, like 2 minutes, 5 minutes? 10 minutes, sweet. So if I have a 5th degree polynomial, this is kind of, basically, this is the fundamental theorem of algebra. If you have nth degree, you can have nth zeros. That's it. So 5th degree is going to have how many zeros? 5. Now that's including real and imaginary. So really the only thing that's going to change here is that I can have an imaginary solution. That's it. That's it. You do the exact same stuff. What's that? Yeah, and this one, yeah, correct. Because you have a 5th degree polynomial. You'd have to have 6 terms in the sequence in the polynomial itself. So here we'd have to throw a placeholder in at the cube. And I have tail of 6 and a leading term coefficient of 1. So my possibles aren't terrible. My possibles are going to be plus or minus 1, 2, 3, and 6.
We have 8 possible zeros.
Yep. And I just go through here. Start at 1.
Do you have to erase it, or can you just like rewrite it out? Because erasing it bothers me.
If you want to rewrite it, by all means, go for it. All I'm saying is, some of these problems, you can try it. You might have to do 4 or 5 of these, and it just takes up so much space. That's all.
But like then you get all those little erase marks, and then you can't tell what you wrote.
Then get a better eraser.
Diverticulitis.
I'm not complaining. I'm just saying.
No, it's fine. If you want to do it that way, it's
You
fine.
just bring like a whiteboard.
I should. I should bring a whiteboard. That'd be cool.
You can change spots.
Hey, I found one!
See, I told you.
Yay! Got lucky. Found a 0 at the first try. Unless I screwed up. Someone said it didn't work. Did it work?
It worked.
Okay. So 1 is a 0, which means I have a term already of x minus 1. Notice, I'm writing these off to the side so I don't forget them. Okay?
And now switch it.
Double check it. See if it's a duplicated 0. Always check to see if it's a duplicated 0.
So what are you doing?
Just flipped it backwards.
Hey, look at that. It's a duplicated 0.
It was her.
It just means it's in there twice.
Man, you were just.
It means it's x minus 1 quantity squared. It means it changes. You can, when we get done, I'll show you. It means it's changing direction at 1. That's where that comes from. So now I know it's a duplicated 0.
Can it be a triple?
Might as well see if it's a it could be a triplicated 0.
I feel like.
Probably not.
What are the chances of that actually happening?
Well, wouldn't it be just 50-50? It either happens or not.
It
You're
doesn't
right.
work. It doesn't work.
But
No.
then, what would it be if it was like a triplicated zero?
Just try it.
So we're trying negatively. I don't think it does. It didn't work.
It didn't work.
Okay. So 1, -1, -1, 1, 0, 0. Didn't work. So I try it again at 2. 1, 2, buckle my shoe, 3, 4, shut the door. That didn't work. Nope.
Negative.
It's negative.
We'll try it at -2, see what happens.
Wait, why do you have 2 -1s?
Because of duplicated 0. Yay!
X squared minus.
What happens, Trap? As soon as you find a 0, check it again, because sometimes it's duplicated.
Yeah, but you have 1, -1, -1, 7, -1.
Yeah, I do. That's from here. I just because why are these like that?
I got 1 right here.
0 at -2. Term is.
X plus 2.
So now I've gone from 5th degree to a 4th degree to a 3rd degree. Now I'm at a squared. So this is the same thing as saying x squared minus 2x plus 3. What times what's 3 you add together to get negative 2?
Negative 3. Wait, that would be negative 3.
It doesn't. It's not factorable. Quadratic formula.
You were looking at
why is
my
That's all that.
Wouldn't it be negative 3 and 1?
No, because that would add, that would multiply into negative 3, not positive 3.
It won't work because if you use negative 3 and 1, you get negative 3 at the end.
Well, you could have just.
So now, this is the case where when you're trying to find all your zeros, sometimes you do have to fall back to the quadratic again. Yes, sir?
You have to put a placeholder.
You always put placeholders, whether it's long division or synthetic division. If you don't do that, it won't work. Because the way that the process for these things work is they have to be in the descending order with the correct degrees. It's basic rule for all this stuff, long division and synthetic. Okay. Otherwise, it skips itself out and it won't work right. So what do we get? 4 minus 12 is what? Negative 8. So we get 2 plus or minus the square root of negative 8 over 2. What's the square root of negative 8?
I root 8.
That's I root 8, but what's the square root of 8? 2 root 2. So let me move this over here. I'm going to get 2 plus or minus 2I root 2 all over 2. In this case, what simplifies?
2.
The 2's.
So then it's plus
So
one.
you get 1 plus or minus I root 2 are my other zeros here. So you have zeros at 1, 1, negative 2, and that. So there are 5 possible zeros, 3 real, 2 imaginary. That's how this works. Okay? Let me give you some of these to work on. Two parts here. Okay. I believe the first ones are real zeros. I think one of them says just what are the factors, and the other one is find the real zeros. And then the last two are find all possible zeros. They're a little bit more of the higher degree polynomials and going from there. But it all stems from just listing the factors of the tails of the constant divided by the first and just go through it. Erase, try not to fling those at each other. Wear safety goggles.
No.
Helmets. Pith helmets. Yeah. What'd you learn in math today? I learned how to fling erasers.
I can only fling it backwards.
Yeah, Maddie tried flinging it at the wall.